Alright, I am here to record Chapter 1 yet again for script programming. Those of you who are in class knew that it crashed last time, so hopefully it works this time. So, alright, Chapter 1. Here's the PDF from the book, Chapter 1. Okay, the book starts off about talking about computer science and why is it important. Well, first of all, I'm not going to cover the entire book. You're going to have to read some of this stuff on your own. It's actually a very interesting read, so I recommend you do it. Computer science is pretty much programming. I actually have a degree in computer science. I guess I have a couple of them in computer science, which means I've taken a lot of programming classes. I've taken every language you can think of. You know, let's see, I did assembly, Fortran, C++, C, Pascal, COBOL, all of them. Okay. Python is a newer language, but it's a very popular language. The reason we're teaching Python in our script programming class now is because it's so popular and so easy to use. So we will be looking at some of that today. Okay? Alright, so I'm going to probably pause a couple times through this, but no big deal. I'll finish it. Alright, so what they talk about here is computer science is a study of algorithms. Algorithms are basically ways to figure stuff out. Okay? Everyone uses them all day long. For instance, you drive to school in the morning. You use an algorithm. Which road to take. Where to park in the parking lot. If this first spot is full, go to the second spot. So that is really what an algorithm is. Okay? And what we do in computer science is we take languages like Python and write programs to solve these algorithms. Okay? They got a couple statements here which are actually really good. Computers are dumb. They really don't know anything. If you just bring a computer and put it on a disk, it's going to do nothing. I actually have a computer sitting right behind me in a box. It's doing nothing right now. Okay? It needs to be told what to do. Okay? And that brings up point 2. They only do what they're told to do. Okay? It says computers do what you tell them to do really fast, so they appear smart. Okay? Computers run programs. And programs tell it what to do, and they do it very quickly, and they're very good at it. So that's what makes you think they're smart, but they're really not. If you tell the computer to do something stupid, it will do exactly what you tell it. Alright. Also says computers don't remember anything unless you tell them to remember. If you don't tell it to store your data or save your data, you're going to lose it. For instance, writing these Python programs, if you don't tell it to save, you're going to lose it. Okay? It says they take your instructions literally. They do exactly what you tell it, nothing more, nothing less. There's a joke on my door on my board over here. Actually, let me go read it. Hold on one sec. All right, I went and got it. Okay, the paper's called "The Problem About Being a Programmer." So my mom said, "Honey, please go to the market and buy 1 bottle of milk. If they have eggs, bring 6." So what did the person do? Well, he brought back 6 bottles of milk. She said, "Why the hell did you bring back 6 bottles of milk?" And he says, "Because they had eggs." If you read the first statement, it says, "Honey, go to the market and buy 1 bottle of milk. If they have eggs, bring 6. We're still referring to the milk. So it didn't say, if it has eggs, bring back 6 eggs. Still referring to the milk. Okay? So they only do what they're being told. Okay? They take your instructions literally. If you tell them to do something dumb, they do it. It also does what is told in exactly the order you tell it to do. Okay? So why computer science? I think it's because it's fun. There's a lot to do in it. You can actually make your life so much easier. I made a discussion post with a student this week who was saying he's a network administrator. He's been one for 14 years. Now he's taking some programming classes. My question is, how are you possibly a network administrator for 14 years without being a programmer? For instance, if I have to add 1 user in a system, no big deal. I can use the GUI interface. I can do the whole right-click add, so on and so forth. But if I'm going to add 1,000 users, do you really think I'm going to right-click add new user? No, I'm going to write a program to do it. It's going to extract the data from a file. It's going to do it all for me. So I find it hard to believe that you can do a network administrator job for 14 years and not be a programmer, or at least have some programming background. Okay? There's a lot of stuff out there. They talk about it a whole bunch in here. So just read through this. They do talk about, some of the different, like, schools like MIT, they talk about CERN, they talk about a bunch of different things. So please look through this section. Okay, all they're talking about GPS. GPS is commonplace today. I'd say most of us probably have multiple GPS systems at any one time. I use them everywhere. Okay, let's see what else. So they go on. I'm not going to go through all this stuff. Okay. Oh, they talk about packages being delivered by UPS. I get packages all the time because I use Amazon Prime. If you don't, you probably should. It's pretty cheap. But they always deliver via UPS. And I always get a text message telling me when the package is going to be delivered and when it has been delivered. Very, very handy feature. Okay. All right, I also talk about airports, how the bags go from one place to another. There's actually a TED Talk out there about a guy who wrote a program to manage a warehouse. It's very, very interesting. Let me see if I can find it real quick. Hold on. I didn't find it real quick, and I don't feel like taking a lot of time, so you guys can find that one if you want. But all right, but they go on to tell you a lot of different stories, so please look through this. Okay, so why is it important? Somebody has to be out there writing the software. Somebody has to be out there doing this stuff. Okay. It says you'll be able to apply new problem-solving skills. Hopefully, by the time you get done with this course, you at least know how to use the basic elements of Python to solve very basic problems. You'll also gain some logic. Okay. You'll learn about processes and how they work. Okay. You'll understand and apply abstraction. We're going to talk about that here in a minute. You also learn to think and communicate more clearly. Yay! Okay. Sorry, I'm still trying to get over my cold. Okay. So, problem-solving strategies. This is a strategy is a high-level idea. Hopefully, you probably have a strategy for everything. So when I go shopping at Walmart, I have a strategy of exactly what I'm going to do. Now, if it's me, I go straight and get what I want. Not everybody does that. Your tactics are the methods or pattern, okay? The tools are the specific thing. In this class, we're actually using Python, okay? All right. And I'm not going to read through all these stories. They go on and on and on and on, okay? But they do talk about a couple things. There's this strategy called simplification, okay? Simplification is a strategy that reduces a problem to a trivial size. Sometimes you look at the whole entire problem instead of just the small parts. I actually bring that up a lot in my programming classes because I'll assign a problem. Well, the first problem, very simple. But later on in the class, they get more complicated. Okay, and I'll assign one. And I have students who read the entire program requirement and try to write the entire thing at one time and hit compile and it doesn't work. Break it into smaller pieces. Okay, do these small little pieces at a time. Get that to work. That's pretty much what simplification is. Okay, then they talk about generalization. So this technique enables you to go from one or from more specific examples to a solution that can be implemented in a program. It's I don't know how to say it. It's making things easier. And they give you an example here of counting. I think this is about clapping hands or shaking hands. But they have a math formula here. N times n plus 1 divided by 2. I'm actually going to put that in Python. I'm going to say I'll say n equals 5. We really haven't talked about this part yet. But what I did is I just assigned the value of 5 to n. N times n plus 1 divided by 5. Okay. Now, if we look back at the picture here, there's our, I'm sorry, divided by 2, wasn't it? Did I put divide? Yeah, but divided by 2. Okay. To solve their thing here, they have n times n plus 1 divided by 2. Did I correctly do that? Well, let's see. The answer is 25.5, which is incorrect. The reason is there's something called order of operations. If you look here, we have parentheses. Parentheses always comes first, then multiplication. See, without this parenthesis in here, right there, what happens is it becomes n times n. So if n is 5, so it's 5 times 5, which is 25, plus 1, which was 26, and divided by 2. Okay? But really, this part should have been done first, we should have added 1 to it first and then multiplied it, then divided by 2. Okay? So if I redo this, n times n plus 1 divided by 2. What will happen now is it will add 1 first, then it starts from the left, and it'll do 5 times 6 divided by 2. We get 15, which is the correct answer, because this becomes 6. 5 times 6 is 30, divided by 2 is 15. Okay, and there's the answer they're looking at. Now they do it with 11. Now let me do it with 11 to see if, make sure it works. So n equals 11, n times n plus 1 divided by 2 gives us 66, exactly like he got it there. Okay. Alright, I really don't know what that picture means, but we're going to move on. Alright, so in fact we can prove the form and give us the correct answer by using representation, which we did. We actually put in numbers. We actually got it to work. Okay. Continue on. They talk about different programming languages. Okay. Python says, why did we choose Python instead of C++? The answer is simple. We want to focus on learning the problem-solving strategies and techniques that computer science uses. Okay. There's whole bunches of language out there, you know, like they mentioned here. Java, C++, so on and so forth. They are great languages. They're actually very more powerful than Python. But Python allows you to do, what can I say, do it with less work. Make it easier for yourself. Okay? So, alright. And we're going to actually see how all that comes into play here in a minute. Actually, I showed you all that on the introduction video. I showed you the hello world. Okay, when you first run Python, this is what you get. It's exactly what I got. It's the Python shell. Okay. Now we're going to get into actual components of the language. In Python, they talk about objects. An object is a number, is a variable, is anything. It's not really the same as they describe it in other languages. But, you know, in Python, an object is anything. Okay. Now they start talking about primitive elements here. Primitive elements are like numbers, like integers, characters, stuff like that. It's just primitive elements. Now I'm going to have to switch to the next set of pages here. But primitive elements are the very basic ones, and we use them every day. Alright, here's the next page. So with primitives, we have integers, floating point, and complex. Integers are like the number 5. Floating point are ones with decimal points. Complex numbers are like imaginary numbers, or more than that. Actually, I'm going to walk through these examples right here real quick. I'm going to put this off to the side a little so we can see it. So when I say 2 plus 2, notice Python just tells me 4. Okay, 100 divided by 7 or minus 75, give me 25. It's just giving me the answer. So if you want to do some very basic math, Python's awesome. It just does it for you. Okay. Now, here's where it gets different. Okay, if I do 14 divided by 2, I get 7. Okay? Now, you'll notice this first one here has 2 slashes. This has 1 slash. This is what's called integer division. Okay? Saying take 14 divided by 2 and give me an integer answer, so I get 7. 14 divided by 2 without that, with just one of them, gives me the floating point number. Okay? Now, let's go with the next one. 15 divided by 2. So 15 divided by 2, let's do it both ways. Okay? They're not the same, because integer division just gives you the integer answer, not the rest. So 15 divided by 2 with the floating point answer is 7.5. And then we get into the last example, which I think I require on your assignment as well, is modulus. Okay, 15 modulus 2 is 1. Okay, what that means is what's the remainder. Okay, so think of the old math we did as children. Take 2, put it in front of 15. So it's, you know how you put that divisor symbol over 15? So it's 2 divided by 15. 15 is underneath the divisor symbol. So 2 goes into 15 7 times. So 2 times 7 is 14. 15 minus 14 is 1. So the remainder is 1. Modulus is what this is. That asks for the remainder. We will cover that more as well. Okay. Now let's move on. In Python, they talk about the read, eval, print loop. Okay. The program reads input, evaluates the input, and prints the output. That's exactly what it was doing here. It's sitting there right now waiting for input. If I type in something, it's still waiting for more input. Then when I hit the enter key, it evaluates it and outputs the results. Okay, very simple. Okay, and they talk about the 3 lines right here as being the Python prompt. Okay, it says Python expressions are a combination of multiplication and division, addition, subtraction, or integer division. Now, multiplication, some of you might think multiplication looks like an X. You actually do it with an asterisk, which is above the number 8 key. And division is this dude right here, the slash. Okay? Alright, and I already talked about the whole integer division part, so we're not going to walk through that. Floating point are numbers with periods. You know, with, yeah, decimal places. That's what I was thinking of. Okay. Here are some examples. Now, let's look at these for a second. Here they're saying 2.0 plus 2.0 gives us 4.0, which is correct. Then what's the difference between that one and this one? Well, in Python, it looks at this and says, okay, I have an integer. Do you agree this 2 at the beginning here is an integer? That's an integer. That's a floating point. Okay. Oh, man. What the compiler does is says, hey, we are taking an integer and a floating point. A floating point is a much bigger data type. We're going to add them together, and since we have a large data type, we need to store it in a large data type. So our answer is floating point. Okay. Same with division. It says, hey, the answer, this type of division could give us a floating point answer, so the answer is always floating point. Okay. We can also do exponents in Python. 2 to the third is what? It should be 8. Okay. So that's 2 raised to the third power. Okay, let's do a big one. 128. Can you give me that one? Oh, very nice. Very huge number. All right. So, we also have complex numbers here. This is scientific notation. 1.33e plus 5. You know, we're not going into that. That's not important at this point. And like they say here, notice that you can use floating point numbers as scientific notation as part of Python. We talked about that. It's just not covered much in here. Okay. And they also talk about precision. Okay. It says one of the disadvantages of using scientific notation is that you lose some precision in your result. If you want to get the exact results, integer allows us to do calculations to unlimited precision. Okay. Let's do that one. Oops. 500. Wow. Look at that. Very nice. Very, very large result. Okay. Alright, let's continue on. Complex numbers. I like what they said. We will not go into any more information. These are imaginary numbers. I'm not a math teacher, but they're represented with the letter J in Python. So if you really want to know more about them, ask Google. Okay? Alright, here's an example of all the different data types. You're free to look at them if you like. Okay? Alright, here's what I was talking about, where it changes the type. If either argument is complex, the result is converted to complex. If either argument is floating point, the answer is floating point. If for all arguments, both must be plain integers, and then no conversion is necessary. So up here, if you have both integers, right there, your answer becomes an integer. Okay? Your answer is an integer. Alright. But beyond that, if you have integer and floating point, you end up with floating point, so on and so forth. Alright, let's continue on. Okay. I think we talked about int and float enough. You can use type conversion. This here, int 3.9999, will convert 3.99 into 3. It basically truncates it. Actually, let's do that one. Int, I gotta We gotta click down here. Int 3.999999. Okay, there you go. It converted it, and I think, not positive, this should convert to 3.0. Yes, it does. Okay, good. All right, wasn't positive on that. Okay, next thing they talk about is naming variables. Actually, hold on a sec. Sorry, I'm coughing a bunch here. Okay, this is very important. That was called an assignment statement. Okay, they mentioned name. Up in my little thing here, I used n. N is the name of my variable. N equals 5. Okay, some of you think that's the equal sign. It's actually the assignment operator. Okay, what this is saying is take the number 5, assign it to the variable n. Okay, so then from this point on, n is equal to the number 5. Okay, it's not like the equal sign you used earlier in life. We will cover a whole bunch more about that later on. But you come up with the name, the assignment operator, and then the expression. The expression is solved, is then assigned to the specific name. Okay, so we got the left-hand side, which is the name, the right-hand side, and then we have the assignment operator. So the left side contains the name we are assigning to the right side expression. All right, easy enough there. Okay. All right, I actually typed all this in last time. I guess I can do it again now. Let's find the bottom here. Pi equals 3.14159. Okay, we just assign the value to pi. Radius equals 8.0. Okay. Height equals 16. I need to move this over a little so I can see it all. Base area equals pi times radius raised to the second power. Now you notice I'm not putting in all the spaces that he does. That's fine, it works either way. Cylinder volume equals base area times height. Almost done. Now what is our base area? I can just type base area and it will tell me the answer. The base area is 201. Mine is rounded where his is not, but that's fine. Okay. The cylinder value or volume is that which matches his, but his is, mine's rounded, his is not. It's because we're actually using a different version of Python. I think he's using 2, we're using 3. Now, one thing I did in class, if I change, now let's look at the radius right here. See this base area? Base area equals pi times radius squared. Okay, everybody see that? Right there. Well, so what if I change the radius? So I'm going to say radius equals 18. So now it's larger. Okay. So since base area is based on radius, base area should not be different. So I'm going to see what base area is. Base area is the same. Why is that? Well, because this program is doing one thing at a time. It's not looping, it's not going back. I would have to go back and take this data right here and run that again. And if you want to know how I did that, if you click, if you click into the line somewhere, and it brings it down to your current position. Okay. Now if I type base area, so now I can go up here, I want base area. Now you see every different base area. So it did update, but I had to run this assignment operator again because base area is just a variable. It didn't continually update. Okay. All right. So we talked about all that there. That's just a visual representation of that. They talked about exactly what we did. Okay, and now we're done with those. We're going to go on to the next page here. All right. So we pretty much talked about all that stuff there. Okay. There's certain keywords you cannot use in Python. Okay. It says some names are reserved for Python's use. These are called keywords. Correspond to important Python capabilities you will learn about later. We're going to look at some of them. And, continue, else, for, import, not, raise, assert, so on and so forth. All these things are important to Python. And you should not use them. You should not make a variable called global. Okay? And we'll talk more about those when we get to them. Okay, I'm not going to walk through these exercises. Now, abstraction. Alright, abstraction is defined as a concept or idea not associated with any specific instance. For instance, square root. Okay? I can use, let me bring up my calculator here. Okay, I have a calculator here. Okay. Do I have a square root sign on this one? Naturally, I don't. Where is my square root sign? That's weird. I guess it's got to be in there. I don't see it. I must be missing. Okay, but square root, y'all know what square root is. Okay, square root does not only work with one specific number. So you cannot say that square root only works with the number 4. Square root works with any number. Okay, so there's a layer of abstraction. Square root was not written just for the number 2. Okay, do you need to know how square root works to use it? Not really. Okay, and here they're talking about something called a black box. One way of thinking about functions are black boxes. Okay, I drive a Chevy Volt. Okay, excellent car. Y'all need to get one. They're great. I don't use gas. Costs me about 25 cents to drive to work. But do I know how it works? Well, actually, I've done a lot of research on it. But do I need to know how it works to drive it? All I need to know is I get in, put my foot on the brake, hit the power button, the car turns on, and I drive. Okay? All the rest of the stuff is hidden from me. Okay? It's like they say, the black box. That's how a lot of things are in programming. Okay? You call a method. Like we're going to use, actually let me do it right now. I'm going to say print something here. Print, I can get down there. Print hi. Okay, that printed hi on the screen. Okay? How did it do it? I don't know. Do I need to know? No, I don't need to know. All I need to know is it did it. I called the method print, passed it a string, and it appeared on the screen. So it's hidden from me. Okay? So since Python contains many abstractions, many of the new things we will see in Python are in fact abstractions built in the primitives, so it allows us to use the primitives and do different things with them. Okay. The next thing here is turtle. We're going to look at turtle. Turtle's kind of cool. But to use turtle, we have to bring in a module. A module is like built-in functionality that somebody else made that we want to use in our program. Okay? To do turtle, we need to import him. So we're going to import turtle. What that did is it took all the functionality of turtle and just brought it into my program. Okay? Pretty simple stuff. Okay? Some of the stuff we can do, we can check his position, his heading, his color, his tail. We can do all kinds of stuff with him. And here's the methods. Okay? We can create a new turtle. We can move him forward or backwards or right or left or so on and so forth. We're going to see how all this works. Okay? Now, here's the code for it. So I'm going to actually do this code. So I already did import turtle. Okay? Now, if I just type turtle by itself, it comes up here and it says, hey, turtle is coming from the turtle Python library. See that? Okay, easy enough. Okay. Now, they use a turtle's name of Gertrude. I don't like that. I'm going to use Gus. Gus equals turtle. Remember, that's the name of the module. Dot turtle. Some of you probably saying, what the heck? Hold on. I'm trying not to cough into your microphone. Alright, so this line here, Gus equals turtle.turtle with parentheses. Gus is the name of my turtle. It's the name of the instance of the turtle object or module. Okay? Now, when I said turtle.turtle, it says Gus is equal to turtle. Remember, turtle is our module right here. Gus equals turtle.turtle. This is the constructor who basically says, give me a new turtle. I can actually have two turtles. This is a good idea. Oh, and it did it. There's my turtle. Okay. Now I'm going to say Sam. I should be able to have 2. Let's see what that. Can I have 2 turtles? Okay, I should be able to have 2. Okay. I think they're both on the same screen. We're going to find out in a minute. How am I going to keep all these on the screen at the same time? I don't know. We'll figure that out. Basically, this says, create me a new turtle. Sam and Gus are my 2 turtles now. Okay. Now, I just want to type Gus. Just by itself. And what it tells me is Gus is a turtle object at this specific memory location. What that means is the actual turtle object is stored in my memory of my computer at that location. It's a hexadecimal value. Okay. Alright, now let's move Gus forward. Gus.forward. What they're doing? Yeah, let's move him forward by 100. Okay, now actually let me go back a little. When I started typing this forward thing here, watch what it did. It automatically, you can't see it. Let me raise it higher. Okay. There. It comes up and says distance. Move the turtle forward by a specific distance. I know. So, well, let me get it totally in the middle of the screen so you can see the whole thing. Alright, there it is. Move the turtle forward by a specific distance. So if I say 100, and hit enter, Gus has now moved forward. Okay? Now I'm going to move Sam forward now. Sam, let's see. How can I get this thing and see him move? There we go. Sam.forward. 100. Now watch what happens to this arrow right here. This should be Sam. Actually, let's move him. Let's just move him 5. Let's just move him 50. Okay. So this arrow right here should move right to about there. Let's check it. Ah, what'd I do? Oh, helps if you spell forward correctly. Click back in there. Come on. Yeah, that darn typo does it every time. Okay, so there we go. Sam now is catching up to Gus. Okay. Now I'm going to, let's see if I can't shorten my screen here. I'm trying to get all this on the same screen so you can see him move. Okay. Alright, so we moved him forward. Now let's turn him right. Gus.right 90. You still can't see him, can you? Move him down. Okay, so now this is saying Gus go right. You see Gus turn right. Then Gus forward. 50. There you go. Gus went forward. And if we want to find out his position, we can ask for his position. His position is 100 by 50. Negative 50. And the heading, well, what's Sam's heading? Sam is still heading 0 because he hasn't turned. Okay? Can I make Sam turn? Sure. Let's go Sam.left. Whoops. Left 90. Actually, let's go 45. There you go. Now let's go Sam.forward. 50. Oh, I did it again. It's only when I do Sam. I don't know why I have an issue. There he goes. Now I can do Sam.position. Tells me exactly where it's at. So it's a little bit of GUI built in here, and we can play with him. Okay, let's move on. Alright, once you start the turtle method, you'll see that he moves. He does all kinds of cool stuff. You can see the lines and the dots and all that stuff. So pretty much talked about all that already. Oh, they talk about parameters. Let's go back and look at our code here. Okay, you'll see right here when I called Sam forward 50, I put a 50 in the parentheses right here. That is basically the parameters I'm passing to the forward method, which we're going to learn more about next time. Okay. Now position, you'll see I put nothing in the parentheses, because that doesn't take any arguments, or it doesn't take any parameters. You just need to run it. Okay? Alright, let's continue on. It shows what he did, blah, blah, blah. Okay, writing your own function. This is actually where this is where we're going to leave off. But we have these functions here. Let me bring this back up. You have this forward function, this position function, this left function. These are functions people wrote. Okay, you can write your own. You can use def for define, then you give it a name, define the function name, list the parameters it's going to take, and then what you want them to do. Okay, that's how you make a new function. Okay, and that's pretty much where I left off in class, so I'm going to stop here, and we're actually going to make a function next time. Okay, all right, hopefully this helps everybody.